Like I told you from yesterday, this class is going to teach you foundational skills. And so I was telling you yesterday, I started off with my story, how I got into the IT industry, how I have been helping hundreds of students get a career in the IT industry, and what it takes to get a career in the IT industry. In my opinion, a student has to have a will. Student has to be gritty. I don't know if you guys know what grit means. Grit means a burning desire to achieve something. As long as you have that burning desire and will, you can learn the skill. And the other thing is, obviously, you need to have a mentor and a guide who can hold your fingers and take you from point zero to earning 120K salary. It is absolutely possible. We have done it. This is what we do every year. And we have hundreds of these students in the market already. Now, um, we started off talking about the overall IT industry and what you can. Let me see if I can share my screen over here and pull up my PowerPoints. We can briefly go over those PowerPoints because today is very important day. We're going to learn about the hardware layer. So let me go ahead and share my screen right now. So we talked about the foundational skills, Linux, understanding the bare metal hardware layer, because that's where Linux operating system runs. And then we're going to talk about virtualization and cloud. And then we will get into the AI infrastructure. And so I talked about learning Linux. Before we learn Linux, we are learning Linux in parallel. But before we learn Linux, we need to understand the hardware layer in details, working with these big bare metal servers. And today I'm going to show you three different type of bare metal servers. We're going to understand what their components are. Why we're going to learn about the hardware? Because I told you as yesterday, there are core IT elements, pillars of IT. You can find hardware, you can find software, you can find networks and data. All of these things together make the IT industry run. And so therefore, we're going to start off by learning the hardware layer. Then we're going to jump into the software. However, I had you started with the software as well when you logged into one of our Linux server through your terminal. And so that's the operating system. So there's always a hardware side. And then on top of the hardware, there's a software. Everybody understands these things because this is the time we live in. We rely on these things for our day-to-day life. You have your cell phone, which is a hardware. On top of this cell phone, you have your iOS operating system. If you do not have the iOS operating system, you cannot interact with this cell phone. Just like that, these servers need an operating system. And I talked about different type of operating system yesterday. I talked about Windows for home users, Mac for home users. Windows is also used at the server level as well, but there's a transition being happening from Windows to Linux on the server side. For the user level, Windows is still dominating. So when you go to the Fortune 500 or corporate environment, you will see people will be carrying laptops and they will have Windows installed on their laptop. For the most part, some of them will use Mac. And then for the servers, they SSH, they remotely access the Linux servers, just like you guys accessed yesterday. Slightly different way. We made it slightly easier for you guys. So that's the operating system we're talking about. So talking about the hardware, today our focus is hardware. We're going to learn different components of the hardware, bare metal servers. We're going to learn about the network elements. And today our focus is working with the server. We're going to start off with opening the server. and show you different components of the server and their function. It's very important for you to become a DevOps engineer to understand these components in the server. So when you have to troubleshoot something, especially performance related issues, you're going to be looking at these components through your operating system. So therefore, understanding their core functionality is very, very important for you guys. The different components of the server, okay? And the different components of the server are CPU, RAM, and the storage. Okay. So, every server and laptop and desktop, they have, I'm going to focus mostly on the main components, which is CPU. Then there's a RAM. Then there's a hard drive, along with other things. Hard drive is where your operating system is installed. OS is installed on this component. Okay. And when you power on the system, the bare metal server or laptop or desktop, certain OS files, operating system files, get copied into the RAM. So that makes RAM store temporary files. It stores files temporarily as it needs them. And then whenever you open up that program, for example, right now, you see different programs over here. You see that I have OneNote, you see that I have PowerPoint, and you see I have WhatsApp open over here, another PC manager, Zoom, Task Manager, Explorer. These are all my programs. These are all of my programs that are continuously running on my server, on my machine right now. And they are sitting on the RAM right now. They are sitting on the RAM. If I click on any one of these applications, guess what? The RAM fed it to the CPU. And the more number of CPUs I have, the better performance I get on my machine. So usually you have a lot more CPUs than one or two. Yesterday we saw how many CPUs I had in my machine yesterday. I think it was 8 logical CPUs. 8 logical CPUs. So that means think of CPU, the working horses, the workers that actually do the job, that actually run your programs. The more workers you have, the more work you can get done. Okay. Think of your hard drive as a big storage area, like a warehouse. Warehouse. Your hard drive is like a warehouse. Stuff is scattered over there. It's sitting over there permanently. And now you have your table. This is where I need to turn on my video. Okay. And now you have this. Give me a second over here. Yeah. So there's a big warehouse. That warehouse has a lot of things stored over there, right? And you also have a table. This is my workstation. This is where I work. Whatever I need, I'm going to have one of my workers go get the stuff that I need to work on, like this server was sitting in the warehouse, which is a hard drive. I brought it onto my table, which is RAM. And as soon as I start working with it, this is where the CPU gets involved. You see how we got the stuff from the warehouse to the table? Warehouse is the hard drive. That's where the permanent storage is. The table is like a RAM. I temporarily brought the stuff onto my table to work on it. This server over here. And now as soon as I open it up and I start playing with it, now the CPU, my brain, is working on it. Okay? So the hard drive is a permanent storage. That's where we store a lot of data. When we have nothing on our hard drive, we start off with basically installing our operating system onto the hard drive. That's where the operating system is installed. As soon as you boot up, you start your server or your computer, some of the files get copied into the RAM. So RAM is like your temporary storage. It's called volatile memory because as soon as you shut down your machine, your laptop or your desktop or a server, the stuff sitting in the RAM, the files, the copies of these files, they get removed. They're not stored permanently. The reason the hard drive pushes into the RAM is because CPU has to execute these files and code. CPU cannot go to the hard drive because the hard drive is the slowest link in your computer. It's going to take a long time. Your server is going to be crazy slow if it has to go to the hard drive. And then, by the way, CPU has its own memory too. Level 1 cache, level 2 cache, level 3 cache, advanced level stuff. We're not going to get into that for now. So, and so that these are the three main components of your server. Do you guys understand that stuff, right? Now, let's talk about what else is there in your server. Well, in your server, you have other stuff. First of all, there is a motherboard, which is a one board where all the components connect. It's called motherboard. Looks like a circuit board. And that's where all the components connect. Your CPU gets connected to the motherboard. Your hard drive gets connected to the motherboard. RAM is connected to the motherboard. And then there are some ports on your server. There is a network board. There is a USB port. There is a video port. And the network part over here is very important. Network is basically gateway into your computer. This basically allows the traffic to come in whenever you visit the website, whenever you basically all the applications are network applications. If I'm talking to you through Zoom, if the network card stops functioning, this communication cannot take place. Even though CPU, hard drive, and RAM is functioning fine, we cannot have this communication. Okay. So now we're going to go ahead and start opening the server and build our understanding of how these servers function. You guys, this is going to be a little boring. For some of you guys, this is going to be a little interesting. My job is to lay down the basic foundation before I move further with the operating system Linux. Because if you don't understand what the bare metal server is, you can never understand the operating system too well. I want you to be a top-notch DevOps engineer, and that starts with understanding the bare metal. Okay, let's go ahead and get ourselves into the server. Now, this is a 1U server. Normally, what you see in the corporate environment, in the data centers, you see these type of servers. And you have a rack, a full rack. And you can put 42 of these servers into one single rack. And I'm going to show you that rack down the road as well. Today, I'm just going to focus on what's inside the server. Then we will talk about what's inside the data center. So this server is called 1U because of its width. So you can have 42 of these servers in a single rack. And at a corporate environment, you have around thousands of racks in one data center, okay? This is not a blade server. This is called the rack mountable server. Blade servers are different. They go into a chassis. This is not a blade server. This is called a rack mountable, okay? 1UR. So even the name starts with the R series or something. This is a Dell machine, okay? And if we look at the back side of this, we have our power supply, and these things can come out. These things can come out. This is a one power supply. You have two of these for redundancy reasons, because you want to have two of these power supplies, because if one goes bad, you have the second one. So this one slides right back in there. You can take this out. As long as you have this one inside the server, your server will continue to run. If you pay attention over here, it has two power cables to connect because you have two power supplies. So that's your part number one. So these are hot swappable. You can, hot swappable means basically while the server is running, you can take it out and you can, insert, or you can replace this one. Now, let's go to the back side of this server over here, and let's identify some of these ports over here. So now this is the back side of the server. Ladies and gentlemen, I was talking about the network card. This is that network card over here. Right over here is your network card. And I also told you that there is a one video connection. This is where you connect your monitor. This is how you get the output. I also talked about the USB. Everybody knows that USB over here. And this is the fiber type of connection. This is the Ethernet type of connection. They are two different types. Fiber is always going to be your faster connection. Ethernet is a little bit slower than the fiber. Okay. What you see over here is a very important port. You don't see this on your machines. You do not see this on your laptops or desktops. This is called iDRAC. IDRAC. iDRAC is your port for the management of this server. So if you're away, you're not in your office, and you need to connect to this server, and the server is not online somehow, you can always connect to this port, and it's like you're sitting in front of this server physically. You can do anything remotely using this port. You can call this port a management port. It is also called out of band management. Okay? So now this is the management port. Okay? This is the VGA port. This is where you connect your video, to get a connection, to get an output on the screen, to see whatever you want to see on this server. And these are the PCI slots. You can expand. You can have different network cards. If you wanted to add more functionality to your server, then you would add more PCI cards into this server. This is a 1U rack mountable server. You see the railings on the side over here? On both sides, there is a railing. Both sides, there is a railing. And this railing allows you to slide in the server into the rack. Okay, so that's the back side of the server. Once again, this is a 1U rack mountable server. This damn thing is heavy. Let's take a look at the back side of this. Okay, sorry, the front side. At the front, ladies and gentlemen, what you're seeing is hard drives. Let's take a look at this. How many hard drives we have? We have 1, 2, 3, 4 hard drives, and these are just empty slots. There's nothing in it. So they are just slot holders. And those are 2, 4, 6. So you can have altogether 10 hard drives in this server. Okay? Now, how do you take out the hard drive? You press on this button, and this will pop out, and you just slightly, gently take it out. This is that hard drive that I was talking about. So there are different types of hard drives. We're also going to talk about the different types of hard drives. If they go bad or you want to take one out, you can simply, and while the system is up and running, powered on, you can take the hard drive and you can replace it. Obviously, it has to do with whether you're running a RAID or whether you're running the operating system on a single hard drive. Okay. So you have these expansion, these slots where you can add more hard drives as you need to put more data on this server. At the front over here, you have the power button, right over there. Now, normally, ladies and gentlemen, when you start working in the enterprise, Fortune 100, 500 companies, they will start you off literally with the data center. They will take you down to the data center. They will test your knowledge a little bit. They will ask you, hey, could you turn on this server? Can you get a console? So they have a lingo that you must understand, and that's what we teach you in this class, the real IT lingo. So getting a console to the server basically means connecting the keyboard, mouse, and the monitor. And so if you're new and you studied from Udemy, nobody's going to tell you what the console is. So therefore, you need to be in this class, okay? My student actually, who started for the New York Power Authority, he was telling me how the senior guy took him downstairs to the data center and had him do the patch cabling and had him take out some servers, replace their parts, and then he asked him to power on the server. Look at this. If you did not know where the power button is, you cannot figure out where the power button is. And so, he was testing his skills, whether he knows where the power button is. So he was able to power on the server, and he called me, and he was so happy and so proud of himself. And of course, I was proud of him too. And so this is what you see over here, the service tag, something that comes out from your server. And the server make and model is VX Rail. It's a Dell server, VX Rail, with the gold CPU. Okay. E560F. So this has the service tag, ladies and gentlemen. All of these servers usually are under warranty. You work with the vendor, Dell. Whenever you have something wrong with the server, whether the hard drive goes bad, RAM, or CPU, you call Dell. They will send a technician. They will come to your data center and they will replace the parts, components. Now that we understand the front and back of the server, let's open up this beast. So it's very easy. You have this opener over here. You just hold it, push it back, and this lid slides to the backward, and you just take it out like this. And you can put this on the side. Okay. So first of all, let's identify the components of the server that we talked about earlier. Let's identify the components of the server that we talked about earlier. All right. Starting with the fastest component of the computer, CPU. Ladies and gentlemen, where do you guys see the CPU? Is this 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 the CPU? Underneath these heat sinks, you have one CPU over here, and you have one CPU over here. And what you see over here, it is called heat sink. The CPUs, because they work so fast, the fastest the CPU, the more heat it's going to generate. So therefore, they need a heat sink, a device, basically a feature, or rather a piece of hardware that basically takes all the heat from the CPU, and then these fans help push these heat out to the backward. Okay? When you run this server, you will see the fans will spin and they will push all this heat. This heat sink is taking the heat from the CPU, and these fans help push it out from the back. In the front, you have your hard drives. I'm going to take it out over here, and I'm going to just put it over here for now. So we have identified two of our components that we were talking about earlier. I got 4 hard drives. I got 2 CPUs. Each one of this is called the CPU socket. This holder over here, and underneath it, by the way, is the CPU. I'm not going to touch this server, but in the next one, I'm going to take out the heat sink and I'm going to show you what's underneath that heat sink. This is your Intel CPU. Okay, underneath this is a CPU, and on top of this is a heat sink. What you see over here, ladies and gentlemen, are the RAM chips that we talked about earlier. My opinion, every single one of you should know these things already. I keep things very simple, and I assume that my students don't have any background. I assume that you guys know nothing about this stuff. And that's how I'm going to lay down your foundations in the IT. And I'm going to make you top-notch DevOps engineer. If you understand what I'm talking about today, then you're going to understand every session that I'm going to teach you. Okay? Okay, now, very good. So now, we talked about how this is a fan, just a fan. Its job is to push the heat out of the system. When these components run, they generate a lot of heat. And this is what you will see in the data centers. You will see a lot of AC, air conditioning. And data center is basically a big, huge room where you have thousands or hundreds and thousands of racks that are holding these servers. These are data center grade servers. You don't work with these servers at home. They are very noisy and they are expensive too. I'm not saying this particular one is expensive. Maybe in a retail now on eBay, you can buy this for a $500, $1,000. But at some point, this server must have cost maybe $10,000 or $20,000, maybe $40,000 at some point, maybe 5-6 years ago. Okay, if you were to go buy an AI GPU enabled server today, it might cost you $40,000. And that's the cost, average cost of a server. So we know that this is the hard drive that keeps the stuff permanently stored. Your laptop also has this hard drive. And there are different types of hard drives. This is the SATA, S-A-T-A, SATA. SATA is this type of connection over here. This is a connection that connects this hard drive to the motherboard. So this is SATA connection. The type of cable it uses at the back end over here somewhere. You see this? So this is SATA. SATA, okay? Controlling these hard drives. So the type of cable that gets plugged, that controls these hard drives or connect to these hard drives, connection is SATA. And the next type of hard drive is NVMe, which is now very popular in powerful systems. NVMe hard drives are basically expensive because they're way faster hard drives. That's all you need to know about these hard drives. There's a SATA hard drive and there's a NVMe PCIe hard drive, which is a lot faster than the SATA. What do you find commonly in data centers and servers? Well, you find these for the most part, okay? You find these hard drives in data center grade servers, in your Dell and HP servers. And the next thing, we're going to look at the RAM. We got our RAM over here. These slots that are holding this RAM, they're called DIMMs. And so each DIMM over here, right over here, you just have to press these two, push them outward. The RAM DIMM will pop out. Ladies and gentlemen, this is the RAM, which is basically the volatile memory. Remember the way it works? You have your CPU. Take a look at this. Right over here. Take a look at this. Take a look at this. You have your CPU, CPU 1, CPU 2. Look how close they are to the RAM. And look, the hard drive is all the way over here. So the data is stored on this hard drive over here permanently. Whenever you click on the application, let's say you clicked on the Zoom, the data gets copied into the RAM and now is being fed to one of these two CPUs. So the more amount of RAM you have in the server, the better it is for your server. The more efficient, the more powerful it becomes. It does not only rely on the RAM, by the way. It has to do with the CPUs too, how many number of CPUs you have in your server. So the way you install the RAM is basically, this is just a RAM holder. This is not a RAM, just like a hard drive. This is the RAM holder. Take it out, throw it over there. And I can install this RAM right over here. You see this? How this over here, this hole is lining up with this right over here, the line right here. So we're going to just simply gently take this and just slide this a little bit, line it up and slide it, and look how it got clicked in. So how many RAM DIMMs do we have over here right now? If we can count 1, 2, 3, 4, 5, 6, 7, and 8. Let's take a look at the configuration or the amount of RAM each DIMM has. All right. Okay. You guys help me identify how much RAM is this. Can you tell me how much RAM is this? 32. So if I have each RAM DIMM is 32, and I have 1, 2, 3, 4, 5, 6, 7, 8. 8 times 32 is what? What do we get? 8 times 32. 256 gigabyte. Maybe they're not all 32 gigabytes. Let's take a look at this. We're going to basically just push this back inside. So this is how. So let's see. We're going to look at another one over here. Usually they're supposed to be similar configuration. What do you guys think? This is your 32 gigabytes. So yes, we have 256 gigabyte server. Wow, this is a beast. All right, so we know that this is a CPU socket. This is a RAM. RAM is usually comes in gigabytes nowadays. And it can go all the way into terabytes. Okay, we have 256 gig RAM. And then, these RAM slots have their numbering. When something goes wrong with this RAM, your server will tell you which RAM slot has gone bad, which DIMM has gone bad. And you yourself, or you will have the field technician or vendor's technician. Vendor basically means Dell or HP, whoever manufactured this server. One of their technician will come. You will take them to the data center. You will pull out the server. Of course, you need to shut it down to replace the RAM. You cannot replace the RAM and the CPU while the server is up and running. So your operations will go down. So let's do a little bit of recap. I got a CPU over here. What is the job of the CPU, ladies and gentlemen? Refresh my memory quickly. CPU does what? Brain of the computer. It processes the data. It executes the instructions. It runs the programs. It executes the instructions. It runs the programs. And where the programs are stored permanently, where the data is stored permanently, the data is stored permanently on your hard drive. Once you open up the program by double clicking, let's say you want to use the WhatsApp or Google Chrome or Zoom, or you want to go to the Instagram, or you want to use your PowerPoint. Once you click on this file saved on the hard drive, where does it go first? Where does it go first? It goes into the RAM. Why it goes into the RAM? Because accessing the data from the hard drive is a lot slower. Accessing the data from the RAM is a lot faster, and it's a short-term memory. I'll give you an example. You guys work exactly the way computers work. Now, let's take a look at this. I do not know my friend's number, Ahmad's number. I have no clue where it is. So I go to the permanent storage. I go into my address book over here, and I go and I search. I am looking up the data on the hard drive. As soon as I click on this and I see his number and I read it, 516643, blah, blah, blah. Now it's in my RAM. 516643, blah, blah, blah. It's in my RAM. So my mind is processing that. It's a lot easier for my mind to process that. You know, when you recall something, what was that? What was that? What was that? You're searching on your hard drive and you're bringing it to your RAM in your short-term memory. And then your brain starts executing that thought. Okay, yeah, I remember that. And that's you bring into the RAM. That's called your short-term memory. And back to the CPU. The CPU, let me know if it gets too boring for you guys. I will start to do something else. Maybe I'll do a belly dance for you guys. I'm told that I don't have a really fat belly, but I'm told I'm good at belly dancing. And maybe you guys will give me more likes, okay? Right. So whatever works for my audience is okay. I'm here to make you guys laugh. I'm here to make you guys learn something new, you know. And yeah, if you guys get to that boring level, I'm gonna have to wear a different hat, okay? So CPU, knowledge checking. CPU, this is called what? I know this is a CPU. The thing that's holding the CPU is called what? What is this on top? This is heat sink. And what is inside, under the heat sink? Is the CPU socket. This whole thing over here is called the CPU socket. CPU socket is a one physical processor. I have two physical CPU sockets, 1 and 2. 1 and 2. Some of the servers have one CPU socket. Some of the servers have, yes. Okay, yeah. Some of the servers have 2 CPU sockets. Some of the servers have 4 CPU sockets. Some of the servers have 8 CPU sockets. And this is important what I'm about to tell you. Each CPU, physical CPU, can actually have number of cores. So it's one physical CPU over here, right? You might think that this is just a one physical CPU. No, this is not a one physical CPU. Inside this physical CPU, there are other CPUs. They are called cores. They are also physical phenomena. A CPU core is basically the number of cores, and when you open up, when you start the server, you can see the configuration, you know, how many cores this CPU is presenting. This may have 4 cores. So then we have 4 CPUs inside this one CPU. And furthermore, to make the things more complicated, furthermore, each CPU can also offer you hyper-threading. Hyper-threading. Hyper-threading is a logical phenomena, is a virtual CPU. Each CPU can offer you 2 hyper-threads. So now, if this CPU, one physical CPU, has 4 physical cores, that becomes 4 logical processors. On top, if it's a multi-threaded, if it has the hyper-threading enabled, then you get 8 logical CPUs out of one physical socket. Out of one physical socket. All right. So now we understand the CPU, we understand the RAM, we understand the hard drive. Right, so I was talking about each CPU, each socket, one physical CPU can, inside of that one physical CPU, you can have different number of cores. A core is like another small CPU fitted inside one CPU. So you can have 4 cores, you can have 6 cores, you can have 8 cores. Different CPUs come with different configuration. You have to read on the CPU specification. I'm going to show you by logging into the terminal, how do we find out how many CPUs we have, CPU sockets. Remember the CPU socket right over here? This guy right here? No, you good, you good, you good. This is a CPU socket. Remember that? We're going to see how many CPU sockets we have in our running server through our terminal. Then we're going to see each socket has how many cores. Those are small CPUs, physical CPUs fitted into a one physical socket. And then on top, those cores inside this physical CPU gives you hyper-threading. Hyper-threading is, if you have a hyper-threading on each core, you multiply that each core with number 2. So to sum it up, one physical socket CPU may give me 4 cores. So that these are 4 CPUs now. If it's a multi-threaded, hyper-threading enabled on that CPU, if it offers the hyper-threading capability, then these 4 physical CPUs fitted into the one socket, one physical CPU, becomes 8 logical processes. Are you ready to explore this on your terminal right now? You good to go? Let's go. I want you guys at this point to go ahead and log into your terminal. Log into your terminal. Let's log into the terminal. I am going to share my screen once again with you guys. And I am going to minimize this over here. And I'm actually going to just move this from here. I am going to literally move this over here. And I am going to start my Google Chrome. And well, I can just come over here. And the IP address was given to you. Go ahead and create a new account. Assad 786. Okay, thank you. The popular number. Assad 786. The popular number. Okay, my email address. Okay, I do sada@linoob.com. And then my password is going to be very strong. I'm going to say welcome 786 and exclamation mark. I'm going to do welcome 786 and 2 exclamation marks. I say create my account. My account is created. This is my user ID. I'm going to take this user ID. I'm going to go log back in. And I am logged in. I'm going to save this information. And ladies and gentlemen, I am on my server right now. And I can see over here, these are all the people that are logged in, or they are logging in right now. How long the server has been up and running? And what is the command to check your load average on the server? Every single one of you need to give me this answer. This is a one interview question. I'm going to start training you guys for the interviews day first. I already gave you one story on the rack servers. The command is uptime. You guys are amazing. Beautifly. How long the server has been up and running? What is this time frame over here? This is the current time on the server. This is the current time on the server. How many users are logged in over here? 141 users are logged in. All of the winners are logged in right now. I cannot use the word losers because that will demotivate you guys. But you know what I mean. you know. But come on, log in, There are more than 140 people over here. Believe you me. Okay. So one more time, 5 more people logged in. Beautiful. The server has been up and running for 3 days, 22 hours, and 22 hours and 33 minutes. We're going to see what this load basically means. These are 3 intervals. 1 minute, load in 1 minute, load in 5 minutes. 5 minutes ago, what was the load? 1 minute ago, what was the load on the server? 5 minutes ago, what was the load on the server? 15 minutes ago, what was the load on the server? But what do these numbers mean, by the way? As you guys see, 1 minute ago when we ran this command, the load was only 0.33. And now it's 98. Let's see one more time. And now it's 131. So what is it telling you about the load right now on the server? Is it increasing or decreasing? Is the number increasing or decreasing? 1 minute ago. Here we go. I'm going to run this command again. Now the load in 1 minute is 1.0. So 1.31 down to 1.0. So it's fluctuating. Sometimes it's going up. When you guys were logging in, everybody was like, hey, this guy is going to yell at me. Let me log in. And the load went up. Now you're logged in and you're sitting idle like, what are we going to do next? The server is like, okay, you're here now. What the hell? I have nothing to do. The rule. I want to check what name I'm logged in as. I'm going to run the command ID. As you can see, my user ID is Assad786. I'm going to run another command, who am I? One word. It will show me that I am logged in as Assad786. I'm going to run the command uptime to see how long the server has been up and running and how many users are logged in. Now we have 159 users logged in. There are more people in this class than the number of users logged in. Talking about CPUs. Remember how I told you there are physical sockets? One physical CPU is like a one physical socket. And then a physical CPU has cores. It might be 8 core, it might be 4 cores, it might be number of cores. These are small physical CPUs squeezed into one socket. And then those cores can be hyper-threaded if your CPU gives you that. And if it's hyper-threading enabled, then you multiply those cores with 2. That's the number of logical CPUs you get out of your one physical socket. Are you ready to explore how many sockets this server that you logged in has? how many CPUs it has. Now that we have seen CPU, we understand what it does. It's the brain of the computer. It's a central processing unit. It executes all the programs, all the processes, all the tasks that we run on our computer. When you execute the command, uptime, it is actually going to the CPU, and the CPU is pulling the information. Now we're going to run the command lscpu, and it's the CPU that is going to pull that information from somewhere, and it's going to show us on our screen. Let's run the lscpu command. The output of the lscpu command is way longer than one page. So we need to divide that output into pages. So normally, now we're going to combine two commands together. So type as I type. lscpu space one command. Now I want to combine another command. There's a key on your keyboard called the pipe sign, which is right underneath the backspace key. Locate your backspace key. You will find the pipe like a line, and you have to hold the shift key in order to press that, in order to make that pipe. So this straight line is called pipe. Pipe is very strong character in Linux. It combines the output of the previous command as an input to the next command. Don't worry about that. We'll show you later on. Now you type more. This will give me page by page output on the screen. It's not just going to fly over the whole output, and I will not see the last page only. Let's take a look at this. Now we got interesting information over here. And what I want to do is I want to take a snipping tool over here. And I'm going to take a snapshot of this, and I'm going to explain you guys what's going on over here. Right here. This is the output we are seeing on the screen. Let's explore this. Let's try to make some sense out of this. My digital pen. So first of all, what type of CPU we have? Well, this is a x86 architect. That means, most of the servers are this type of architect. We used to have Unix running on Sun Solaris. So that was a Sun architect. These are x86 64 architect. That's what you're going to see mostly. The next information that I want to see, I want you guys to help me figure out how many sockets are there. How many physical CPUs are in this computer, in this server? Socket. Number one, it is saying CPUs 144. Well, does that mean I have 144 physical CPUs? Does that mean I have 144 physical CPUs? No. I'm looking for the word socket. Right here. I have 4 sockets. You know what? You know those physical CPUs that you saw, 2 of them? I have 4 in this box right here. I have 4 in this baby. I'm going to show you those. So now I have 4 physical CPUs. 1 socket, 2 socket, 3 socket, and 4 sockets. Now, how many cores? This should make sense to you guys. How many cores per each socket? 18. So I have 4 CPUs, 4 sockets. I have 18 cores. What does that mean? It means I have 1 over here. I have 1 socket over here, and I have 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 processors squeezed into one physical socket. 18 times 4 is what? 72. Now 72 is hyper-threaded times 2. So you have, ladies and gentlemen, 144 logical processors over here. Okay? Does that make sense? Hyper-threaded means that each core can actually work like two CPUs. Physical CPU is a socket. Inside the physical CPU are the cores. Each core, if it's hyper-threaded, can work like two CPUs. It's like virtual CPU. It's just like you guys have a virtual life on Instagram and social media. You're poor, but you show you're rich. Same thing. The CPU has 8 cores, or whatever the number of cores CPU has, that's the actual stuff. And then it is showing to the operating system, look, I can multiply this. I can do two-man's job. Virtualization is everywhere. Okay? So it's 18 times 4, then you time that by 2. Yes. Yes. So come back over here. Here, one socket. By the way, first of all, divide the 18 by 4. What do you get? Yeah. So let's say this is one physical CPU. Let's say, just going to give you the example. This is one physical CPU. And then each one physical CPU, now I'm going to give it 4 cores. Just for understanding. I'm going to give it 4 cores here. I'm going to squeeze in 4 cores in here. 1, 2, 3, 4. So now this one socket is giving me 4 cores. Correct? And on top, if this socket has multi-threading enabled, this is something that your CPU can do or cannot do. Most of the newest CPUs are hyper-threaded. They can do hyper-threading. They're multi-threaded, meaning they can multiply with 2, and this becomes 8. So one physical processor actually can work like 8 processors. That's what it means, basically. So now, who's the vendor over here? It is the Intel that makes the CPUs. And this is the type of the CPU that you have over here. This is the clock speed of the CPU. You understand that? So this is Intel Xeon CPU. And that's a different server, by the way. Okay? Okay, so we got that. So now we know what the physical socket is, and we know how to get the cores. Now let's talk about the memory over here. Let's type the command free-h. By the way, the command, I'm going to explain to you guys what the command over here is. So anything in Linux that you need to do, you have to run a command. That's why it's a little bit challenging, as opposed to Windows, where you simply type the sys information and you have the whole information in front of you right over here. Easy, right? Easy, right? Windows makes it so easy for you, right? How beautiful. But that's one of the problem. It's the crappiest operating system. Just when I power on my computer this morning, 45% of my memory and 40% of my CPU was used just to boot up my computer. Somebody said, do not use the word goddamn, so I'm not going to use that word anymore. Okay. But you know that. Absolutely, Mac is more efficient. Linux is even better. That's why it's used for the servers. Because you and me, we can live with that. We can complain all day long. Companies do not complain. They cut down and they move on to another product. And that's what companies are doing, transitioning from Windows to Linux servers. The AI workloads, the AI infrastructure is highly supported on Linux platform. It can work on Windows as well, but because Linux is flexible, it gives you the power to change anything. These commands have so much flexibility. You can go into the depth of the information. Windows gives you that command line as well. But because it puts so much GUI into it, so much graphical user interface, it takes up a lot of resources. So in my computer, I have 16 gig RAM in my laptop, but in my Linux server, which I'm connected to through my web interface, I have 755 gigabyte RAM. And I'm only using 13 gig of that. 735 is free. And by the way, this is the command, free command, to check your memory, RAM. Memory is always equal to RAM. Hard drive is always equal to storage. Never get these two things wrong. Memory is RAM, hard drive is storage. Okay? Some of you will make this mistake. You will keep referring to the hard drive as RAM, or vice versa. You will say RAM is hard drive. Do not make that mistake. What you see over here, this -H, is the flag. It's called flag. It's an option. It's an option with that command. And Linux, for one command, gives you tons of options. It depends what you want to do with that command. Each option gives you different results. So maybe there is a free, this is basic command, and maybe there are more options. Well, maybe there is a command called -K. Option, not the command. Flag, -K. What is the -K will give me? It will give me this output in kilobytes. Maybe there is a flag called -M, which will give me the output in megabytes. Maybe there's a flag called -H. It says that make it available in a human-friendly format. Human-friendly format. Gigabytes. If it's in terabytes, give me terabytes. If it's kilobytes, give me kilobytes. Don't make me go through those numbers and convert them. We have a byte, bit, byte, kilobyte, megabyte, gigabyte, terabyte. So petabyte, and so on and so forth. Right now, we are very happy with gigabytes and terabytes and petabytes. Okay. So I did not see the GH that you're talking about. Gigahertz, you mean? That's the clock speed for your CPU, gigahertz, megahertz. Okay. Yeah, we'll talk about that some other day. Right now, just wanna. So now the RAM, you can relate to this RAM, those memory sticks, temporary storage. Folks, am I going too slow for you guys? Is this good? Okay. We talked about the hard drive. Let's see how do we list the hard drives in Linux server. How do we get the hard drive information like these guys? How do we get the hard drive information? Before I do that, I want to take you guys into this server, which is a 2U rack server, rack mountable 2U server, ladies and gentlemen. And take a look at the width of this server. Oops. You see, compared to the previous server, this is more wider, right? Two of those can fit in here. Oh, let me disable my screen sharing. Okay. The ones that we saw earlier, take a look at this one, this guy over here. This is 1U, and this one is 2U. So two of those makes this one server. Okay? So now if we had these 20 or 22 of these will fit in a one rack, standard rack in the data center. All right, let me see over here the back side of the 2U rack server. Ladies and gentlemen, what do we see over here? What is this port over here? I trained you guys really well. You should be able to tell me, what is this port over here? Let me move this. Guys, oh, I don't need this. Can you give me a second? That's okay. And move this guy over here. All right, now, what is this port over here, ladies and gentlemen? Ah, no, you guys all got it wrong. This is the management port. This is the management port. Out of band management. This is iDRAC. HP iDRAC port. HP has the same port, but they call this ILO. Okay? This is for the remote management. How do you, and I will show you how to connect to this port. Now, so that's there. This is your serial port. We don't use this anymore. When I was young and handsome, back in 20 years ago, when I started working in the data centers, we used to connect to this port. They did not have this port on the servers. This is the VGA port. This is where you connect your monitor. And now you have this VGA port. Now that I'm old, they brought this, make life easy. But we used to connect this port through a dumb terminal using a serial cable. But this uses a standard monitor VGA cable. And this is your USB port over here. Aha, what we got over here, folks? What are these guys over here, these babies over here? These are your Ethernet ports. These are your networking ports. We can call them Ethernet port. We can call them networking ports. We can call them NIC. NIC, Network Interface Card. Network interface. How many cards do I have over here, ladies and gentlemen? How many network connections can I have? I have 4 cards over here, network cards. I can connect 4 of these cables. This is the RJ45 cable. RJ45 cable. On both ends, you have these connectors. This is one cable, and the both ends has this. I'm going to show you where you connect this connector. One connector goes in this side over here, and the other connector goes into the networking device, which we're going to look at later on. Okay? So let's move. So I have 4 Ethernet cards. The real terminology is Ethernet card. How many Ethernet cards do we have over here? How many Ethernets we have over here? We have 4 ports, 4 Ethernet ports, 4 Ethernet ports. Very nice. Beautiful. You guys are all great. I love how interactive you guys are. And if I don't know your name over here, I don't know who you are. Okay? I already know some of you guys, your names, because you guys are so active in this class. I know this is for free. I know we have been trained in this society, nothing is free in life, but believe it or not, this knowledge is free. And you will learn something, whether you stick to the program or not, but you're going to remember this information. You're going to remember this information till the day you die. I promise you this. Okay? I hope you live 100 years longer and use this information. All right, let's open this guy. All right. Okay. What do we got over here? Ladies and gentlemen, the front. Where is the power button? If you were that guy and the guy took you downstairs to the data center and asked you to press the power button, it's right here. It's right here. You see that? And then this is the USB port. Again, you have a VGA port. You have a VGA port over here. And then this is the front panel, a little screen that shows you if there's any error. And what type of server is this? This is PowerEdge R710. The R stands for rack mountable. PowerEdge R710. The VGA port is used to connect to the monitor. We're going to bring a monitor over here and we're going to connect this cable. And now, how many hard drives does this server has? It has 2 hard drives. Somehow they don't close because my students were here last week and they were playing around and they messed up the whole server. But that's okay. That's what this server is for. So this can have how many ports does this has over here for the hard drives? Now start with 0, folks. 0 to 7. So it can have 8 hard drives. It can have 8 hard drives. Well, somebody genius, thinks that 0 is also a number. So he's trying to, just make that statement over here. 0, 1, 2, okay? He is counting the 0 as a number. It is a number, actually, if you look at it, You got to start from somewhere. And then, what do we have over here? What is this called? What is this called, ladies and gentlemen? Explain VGA port again, please. It's a VGA port. VGA port. And if you have your monitor cable, for your desktops, you will connect to this VGA port. And I will show you down the road how we're going to connect this VGA. And what you see over here is basically the server information, like the serial number, the service tag. When you call your vendor, which is Dell in this case, you give them the service tag number. They know the history of your computer. They know what parts you have ordered. And if you have warranty with them, they will send the person out to replace any parts, okay? And that's also part of your duty as a sysadmin, as a Linux engineer. Not necessarily as a DevOps engineer. As a Linux engineer, it is your responsibility to call vendors to get a support on the servers. So let's remove this lid over here and let's put it over here for a second. All right, ladies and gentlemen, I got my 2 hard drives over here. Going to take them out and put them over here. Same layout as the other server, right? Same layout. Folks, we have a guest speaker over here. He is a student at Linux. His name is Rick, and
Okay. So yeah, I've taken the RHCSA and I've taken the RHOSA, and I will tell you, I've been in the industry 25 years. I'm an older engineer. Linux actually teaches you the concepts and the methodology, versus if you take a Red Hat course, you pay $5,000 and they read from a book and they give you very specific questions. They do not go over everything. They do not tell you everything that you need to pass the exam. And it's done purposely because they don't want a lot of people being certified. That makes it really harder. And I will tell you, I know 300 different Linux, Unix system admins. The RHCSA was like the biggest monster that they would ever run across. Nobody wanted to take it. I knew 5 people that took it and passed it. I knew 30, 40 people that took it and didn't pass it, and they wouldn't take it again. And with Lanoop and the instructors, they give you everything that you need to go through in order to pass the test. They tell you everything, how to set up your computer. They give you night and day. They are available 24/7. I've never seen an outfit like this, and they're a fraction of the cost of any other training that I've seen. And so RHESA, I was a little bit I didn't think I passed the first time, and I passed with a pretty good score. And the same thing with RHOSA OpenShift, which is growing technology. I passed both my exams on the first time. There were some people that had to take the exam more than 2 times. I know one person from Lanoop, but she didn't give up, and we supported her. We give you everything that you need. If you need me to help you with some of the questions or go over it, anytime I'm available, I will do that for you. And that's what makes Lanoop and the family so much better.
Thank you, Rick. Appreciate that. So guys, Rick joined my free classes last year. And I was surprised to know that Rick has 25 years of experience as a Linux systems engineer. And I told him, I said, Rick, what are you doing over here in my class? You don't need to be in my class. It's expensive for you. And he goes, no, I need to pass my Red Hat certification. And I said, bro, we're going to help you. Right, Rick?
Yes.
I said, we're going to help you. We're going to help you pass this certification, and you're going to pass it in flying colors. It's not a big deal. And so, Rick, what is the importance of this certification in the industry? The reason I asked you to come and speak over here, because you have 25 years experience as an engineer. You've been, you've been in the corporate sector. You know the value of this certification. I want you to tell these people what is the Red Hat Certified System Admin, Red Hat Certified System Engineer, and the OpenShift certification means as a system engineer to you.
It stands out on your resume. Anybody else that says, oh, well, I have experience, you have the certification from Red Hat, and you literally go above them right at the beginning. And this is, like I said, I've taken Red Hat courses, and they do not care about you. They don't want you to be certified. They want you to come to them for answers for their support. And I've been in jobs where I knew more than the Red Hat engineers when I had a problem. And I ended up fixing the problem on my own because they caused more problems than they were worth.
Absolutely. So this is the most respected certification. And take a look at this from my last batch that ended in 2026 February. And this is when these students, from between January and February, these students got their certifications. They're all Red Hat certified system administrators. These certificates, if you scan the code, they're legit. You can verify this through Credly, and these are hundreds of certifications we got for our students. I just wanted to highlight the work that Lanoop is doing for the industry out there. Go to the Instagram page, check it out by yourself, scan one of these codes, and go to the Credly, and you will see that these certifications are not fake. They are real certifications, and we have hundreds of these certifications. And some of the students, about 50% of my students, they do not want to be on social media. They do not want to have their names on social media, and I have to seek their permission. So therefore, some of the certifications are not even posted on the social media. And certifications alone do not get you anywhere. They open the door for you, but they do not guarantee you the job. What guarantees you the job is the proven skills in the IT industry. And RSCE, which is Red Hat Certified System Engineer, is one of the hardest certification to obtain. So is the OpenShift. And these are the hottest technologies out there that you guys can learn throughout this program. And Rick, thank you so much for your time, for coming here, for vouching for Lanoop. I didn't want to bring in somebody because I have 500 to 1,000 people from the South Asian community that I have been helping. I wanted somebody from, now he's part of our family, but he joined Lanoop back in year 2025, right? Rick?
Yes.
2025. Yes. He saw the ad on Facebook and ended up coming over here. He made me nervous, to be honest, when he said, I got 25 years experience as a system engineer. I'm like, oh God, we're going to have, some real fun. I got a real system engineer sitting over here. He's going to be correcting me every step of the way. But I think I did pretty good, And
you did great.
Thank you. Thank you so much, Rick. Appreciate that. You can turn
Yep.
off your cam now and let us get back to the class. And so yeah, LSBLK, list block devices. Block devices are hard drives. What you see over here, SDA and SDB, Linux operating system, list your hard drives as SD means SATA and D means drive, SATA drive. Okay. And so A means first hard drive. You know how we saw the number of hard drives in our server? So this particular server has two hard drives, the one that we are logged into right now. It has two hard drives, SDA and SDB. And now it doesn't take a genius to figure out if I had the third hard drive, what would it be? It doesn't take a genius to figure out. If I had the fourth one, what would it be? If I have the fifth one, what would it be? E, S, D, F. Okay, very good. So now you know that on the left side over here are all our hard drives. And how many hard drives do we have? One and two. One and two. Two hard drives. And let's take a look at their sizes. The hard drive number one, what's the size of this hard drive? I cannot hear you, sir. Is that right? Can you guys hear me okay?
You're fine for me, Assad bhai.
Okay, thank you, Rick. Appreciate that. Yeah. You need to increase your volume if you're having a hard time hearing me. This is 3.3 terabyte. 3.3 terabyte. And I will talk about, what the kilobyte is, what the megabyte is, what the gigabyte is, what the terabyte is. Today is all about the hardware. So obviously, terabyte is bigger than gigabyte, and gigabyte is bigger than megabyte, and megabyte is bigger than kilobyte, and kilobyte is bigger than the byte, and the byte is bigger than the bit. That's how it works. But you guys know this stuff because you're playing with the social media nowadays. You're downloading your videos, you have your pictures, and that takes gigabytes. So that's terabyte. My apologies. I'm sorry. It was just out of my control. So the second hard drive, ladies and gentlemen, what's the capacity of the second hard drive? What's the size of the second hard drive? It is almost 900 gigabyte. 900 gigabyte. And if this was a 1000 gigabyte, this would turn what? Terabyte. And so 1000 megabyte turns into what? 1 gigabyte. 1 gigabyte. You guys are smart. Okay. If you don't know this stuff, that's okay. You just never dealt with this before. Perfectly fine. Yeah, I mean, come on, I'm rounding up. 1024 to be exact, okay? You're absolutely right, but look, be realistic. Who cares about the 24? Okay, keep it simple. 1000. Okay, now let's talk about what do we see? Okay, I have two hard drives. And those two hard drives are SDA and SDB. And these two hard drives additionally have different numbers: A1, B1, B2, B3. Oh, sorry, A1. What are these additional numbers over here? Well, the hard drive is a physical phenomena. You can use it as a one full hard drive, or you can divide this into smaller sections. There's a reason why you want to divide. Let me give you that reason. When you purchase a land for your home, yeah, you have a land for your home. When you build your home, do you divide the space into different rooms? Bathroom, kitchen, bedroom 1, bedroom 2, downstairs, upstairs. Yeah? Why do you guys do that? Because to organize things, to keep things where they belong. So partitioning is the same concept. It allows you to organize. Different files will go into different partitions. Yeah, we will talk about partitioning down the road. Today, just understand a partition is a division inside the hard drive. It's a logical division. It's a logical division. The software, the Linux operating system allows us that we can divide the hard drive into different sectors. And those sections are called partitions. Yes, that is correct, Abdul. Okay. So now, today, once again, relating to the information that we know, we are able to tell how many CPU sockets we have. We are able to tell how many cores we have. We are able to tell hyperthreading. We are able to tell how to see the physical installed RAM on our server. We're also able to see the hard drives connected to my physical server through my operating system using different commands. I'm going to give you the most standard one, which is ifconfig. If I stands for inter, F stands for phase, interface configuration, because basically network card is an interface. It's basically the way the data gets into your computer and leaves your computer. If my network card is not functioning, then there's no traffic coming in and out. I cannot be communicating with you. So I am typing that command in the terminal, type ifconfig. And obviously the output is gone all the way up. So I need to use my friend pipe and my another friend more. So I can break down the information into the smaller frames. So if I look at this over here, I have right here. This is my interface 1, 2, 3, and 4. I have 4 interfaces. I have EN052. I have EN051. You remember I showed you the back of the physical server. There are 4 network cards. That's what these network cards are. And they are named differently. EN050. It starts with 49, 50, 51, 52. Let me see what it starts with. Yeah, don't worry about the Docker because this is not the actual network card. This is the actual network card right over here. 49, 50, 51. And then what's the next one? 52. So we have the interface. We have 49, 50, 51. 4 interfaces, 52. We have 4 interfaces. Okay? You cannot type into the terminal, relog in. And ladies and gentlemen, that's where I am going to finish my lecture for today. But before I let you go, I'm going to show you the big beast. Okay? And the big beast, we're going to see how many sockets are there. This is the exact replica of what you have and where you guys are working on. The server. That's the exact replica for that server. Are you guys ready for the big beast? Let's take a look at the big beast over here. Once again, same thing. Unlock this by this latch. Remove the lid. I think I'm going to have to move this screen over there so you guys can see, and we can also see you guys. Right here. Here. All right. Yeah, right here. You're good, Ahmad?
Yeah.
Right here. Okay. Well, this is not a Dell server. This is a big beast. This is your HP server. And I'm going to show you the front of this from here. Where should I move it that way? Yeah, right here. This is about 75 pounds. Heavy sucker. This is your HP server. Right over here, you can see the HP Proliant DL580. HP Proliant DL580. Okay. And this is Gen 9. These are the CPU fans. You can take it out like this, plug it back in. Again, what's the function of the CPU fans? Push out the hot air. Okay. And these are the hard drives at the bottom. Take a look at this. Same structure. What type of hard drive is this, ladies and gentlemen? What type of hard drive is this? SSD. Beautiful. Awesome. SSD are solid state hard drives. Solid state. And now, this is a big guy over here. In order for me to show you, let me show you over here. Now, this has a lot of PCI slots. Take a look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9. About 2, 4, or 9 slots, I would say. Yeah, 9 slots, PCI slots. And you can see you have the module over here in one of those slots over there. And that's where your power supply is. And you can see you have 4 power supplies. 4 power supplies, okay? All of them are hot swappable. How are you, boss? All of them are hot swappable, okay? And the way this server works is different. You have to come this way. You have to come this way. This is different than the regular, your HP Dell servers, okay? I'm going to press on this button over here. And then this comes out. I'm going to have to take this module out like this. And woo! And then I'm going to have to press on these and take this whole thing out and put it right over here. Slide it down. Slide this way. There you go. Beautiful. Oh my God. And then I'm going to take the cover off from here. And where do you see your CPUs? This is a whole different game. Where do you see your CPUs? Under the heat sinks. 1, 2, 3, 4. How many CPU sockets we have? 4. Now, this is the same guy that you guys are working on. I have a bunch of these guys. And now you can see this is over here, some hidden stuff over here. So by the way, we talk about the cores. Each socket has maybe 4 cores. And then there's a hyperthreading available. Right? 4 plus 4 is 8. 8 times 2 is 16. 16 times 4 is supposed to be more. Supposed to be more. Supposed to be more. We got the wrong number of cores. It has 144 cores. 18 cores. 18 cores, exactly. Each beast has 18 cores. Okay? So, and then hyperthreading. Oh no, altogether is 18 cores. And then hyperthreading. So you have 18 times 4, 72 times 2, 144. Okay, sorry, my math was wrong. Let's take a look at the RAM over here, for ladies and gentlemen. It's a whole different game. This beast is different. This is Gen 9 HP, and it has a lot of RAM. Take a look at this. Guys, you have to make my window bigger from your end. Can the panelists please help? How much RAM? Let's take a look at this. This is a DDR. What do you got over here, folks? This is 32 gig. Each DIMM is 32 gig. So how many we have over here? 3. 32 multiplied by 3 with 3 is what? Let me show you how to line this up. This is going to be better view for you guys from here, if you can shoot from here. How to line this up. Let's take a look at this. You see this? This goes in smoothly and just press on the edges. There you go. 34 or 32 I said? 32. 32 times 3 is what? 96. So this one box over here is giving you 96 gig. And how many of these boxes we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 times 96. 768. We got a math whiz over here. And that's what you guys saw when you run the free-h command. Go ahead, run that command one more time. Free-h. Go ahead, run that command one more time. And tell me what RAM do you see over there? Installed RAM. Like I said, the production server where you guys are logged in. Please, what's your question? Sorry, John, I cannot see your question. Let me see over here. Kind of. Please repeat the command. The lscpu, guys. There you go. You have about 755 gig RAM available. Now, I'm going to take out these hard drives, and then we're going to compare. Well, this one has an SSD hard drive over here. What's the capacity? 960 gigabyte. 960 gigabyte each one of these hard drives, and I got 1, 2, I got 4, 1, 2, 3, 4, 5. I got 5 hard drives. But there's more story to it. You know, there's a raid going on. So that's a topic for another day. How do you set the raid? So now you can put it over there. And let me talk to these guys. Wow, what a long lecture and boring lecture that you guys had today. The next class, I want to talk about the networking. Now you understand the server inside out. You understand what is a server, what are the components of the server. I'm going to talk about the networking components. How do we get online? How do we transfer data from our machine to the internet? How is it that you and me are connected through Zoom? What are the devices on the network that connect us? That's the topic for Wednesday. Be ready.